Hello everyone, my name is Ojas Shrivastava and I'm going to give a session on integration service on Grid. So first let's decide on the agenda. I'm going to define this IS on Grid scenario. Secondly, provide the use cases where such a setup could be useful. Um, a demo of creating an IS on Grid from the admin console and then running a workflow on it. In the end, I'll try to explain the multiple IS process architecture and how multiple integration service processes work within one single integration service, which is running on a grid. And I'll close with some first stage debugging tips for I integration service on grid. So quick definitions, kind of prerequisites to this session, like what is an integration service and what is a grid. An application service responsible for running the workflows in the session is called integration service. And a grid is an alias assigned to a group of nodes that allows you to automate distribution of workflows and sessions across nodes. So why use IS on grid? What is the use case? You can basically use grid to increase session and workflow performance. So how we do it is that when the integration service requires CPU resources for passing the input data, formatting the output data, or doing all kinds of computation, or requires disk space and all these resources, a grid can improve those performances, because if you have a performance bottleneck on a particular machine or a particular node due to lack of any specific resource, you can distribute it across multiple nodes if the integration service is running on a grid, and that way we can remove that bottleneck. So that's what the third point is. A grid can improve performance when memory or temporary storage is a performance bottleneck. So when a power center mapping contains a transformation that has, say, cache memory or deploying adequate memory and separate disk storage for each cache instance, then in those scenarios, a grid can improve the performance. So I'll now give a demo of creating an integration service on grid, and then we'll also run a workflow on it. Now you can see this is a grid that I've created in one of my domains, and it has these three nodes, and two of these nodes are currently up and one is not. Now what we're going to do is we're going to create an integration service on this grid. I'll select Power Integration Service and I'll just give it a name. Now when it comes to assign, we usually choose node when we are creating a service on a specific node, and in that case we get to give a primary node, and then we get to give a backup node as well. So if I select any node here, I'll get to give a backup node here among the other rest of the nodes in the domain. So which basically means that this is the node on which the integration service will be coming up, and in case this goes down, the integration service on this node goes down, or it is not able to come up on this node, it will go for the backup node. And in our test case, we are going to create it on a grid. So these are the grids available, and I'm going to select, say, grid 4 and next. So now this IS node grid has been created, and I can just enable this. Let me check grid 4 once again. So this is the grid 4. There are these three nodes on it: OS node, node 02 and node 04. So if you check this processes tab now, you will see there are these three processes there, and there's a node type, node status, and node names. And then there's a process configuration and a process state, and each of these processes has a separate property section. So for this process there is this property section, for this process then this one, then this process this one. Okay, So I'm going to explain a little bit on these. So let me first just correct one configuration here. I'll explain why this is important. Now I'm going to enable this integration service. So while this happens, let's go back to our slides. So while that process comes up, let me show you one very important thing. So if you just noticed right now, in the admin console, there were two tabs for the integration service. There was one tab for the properties, which was the service properties, where we saw that this was the license and this was the node or grid name on which the integration service was running on, and what was the integration service names and all those kinds of things. And then there was the second processes tab where we saw three different processes, each corresponding to the three different nodes in the grid, and each of those processes also had their own properties sections. So this is an important thing. This is not specific to an integration service running on a grid. Even for a normal IS, there are the process tab, which is the actual integration service process that runs on your machine. And then there is a general properties tab, which is about the integration service. So from here, you can kind of understand the relationship that within an integration service, there can be multiple integration service processes, each of those processes corresponding to a particular node. Now, for a normal integration service which is running on a node, the each of those processes, one of them is for the primary node and the others probably for the backup node. And for an grid integration service running on a grid, they are for each of the nodes in the grid. So what are the integration service process? As I just explained, within an integration service running on a grid, there would be as many IS processes as the number of nodes in the grid, and one process running on each of the nodes. These processes could be separately disabled and enabled and would utilize the resources available on their respective nodes like the memory and CPU individually. And you can configure each of the integration service processes in the process tab of the IS in the admin console. So we'll see that now. So this is the integration service. It is up now, and if we go to the processes tab now, we see there are two processes running here and one is disabled. That is the process state. Though the process configuration for all three of them is enabled, but actually one of the nodes is actually unavailable, and that is why that particular process state is in disabled. And if you see the properties for each one of them is not same. So sorry, while the process properties for this first one is says that the pm root directory is this particular directory, and for the second one it says it's an unknown location, and the third one, if you remember, it was initially something else and I changed it back to be the same as this one. So this is very important actually, and I'll shortly explain why. So for an integration service that is running on just a node, it is actually running on active passive node. So what happens is we provide one node as the primary node, and that is the node on which the integration service will always try to come up when you say enable the integration service from the admin console or via a command line. It will always try to come up first on that primary node, and if it is not able to, then it goes for those other nodes. And even if an integration service is running already on the primary node, the other node stays in a standby state, which means that the IS process on this node would be started if something were to happen to the IS process on the primary node. And this is called running the integration service or the IS in an active passive mode. That is, it is actively running only on one node, and the process state is actually enabled only on one of the nodes. So we can go back to the admin console and see that. So here you can see this is an integration service which is configured to be running on a node. And what I'm going to do is I'm going to edit this and I'm going to provide it a backup node, say node 4. And then I'm going to say okay. I'm going to bring it up. Now that this is up, if you go to the process tab of this integration service, you can see that the process state is running for one process and standby for the other one, even though both the nodes are actually available. And the node type of the first one is primary and the second one is backup. But for the IS that we created on grid, in the process tab, even though both nodes are available and both nodes are actually in running also, there is no standby state. This middle process would also have been in running state only if this node had been available. And the node type of all three of them is just backup. One thing I should cover now is that why I change this PM root directory. So what happens is that in integration service and grid, all these processes are actively running and actively performing the functions of the integration service, while not like the integration service on a running node, which is the other node is just standby and there is no actual integration service process. So for a Linux or Unix based machine, you'd see a PM server process on the server if the integration service process is running there. So if there are two nodes and one is primary and one is the backup or the standby node, only on the primary node will you see an PM server process. And on the backup node, there would be nothing. There would be the node process only. And once the primary node goes down or the primary node IS process goes down, then only a PM server process for a Unix machine will come upon the secondary node. But for an IS process running on a grid, you will see PM server process on each of the nodes that are currently available and are in the grid on which the integration service is configured. Now, for these separate PM server processes to communicate between each other, they need a shared directory. So that is why we configure this PM root directory process accessible by the node to be same for each of these processes. So if I were to use this process as well, I have to first make this PM root directory the same as the other two. That way they can share the location where they are all writing the session logs, where they're writing the workflow logs, where they're creating the caches and the source files and the temporary storage files, log files, all those files they can kind of share with each other and access each other's files, which they require to kind of run inside in a grid. So that inside one service there are multiple processes, so they need to communicate with each other, and for that this particular directory has to be shared and accessible by each of the nodes. So each of the machines on which these IS processes are running should be able to access this particular directory. Okay, so as I said, now the IS on grid scenario is different from the IS on node scenario. The IS on node scenario was active passive and IS on grid scenario is active active, which means that each of the nodes inside the grid, if the IS is integration service is running, then there will be a process, integration service process on each of the nodes in the grid, and it is capable of performing all of the functions of the IS, and only requirement is that each of these should have the same PM root directory and each of the machines should have access to this particular directory. And this is called the active active mode, and the other one was called active passive mode. So I already showed you inside the admin console the processes running in the running state, multiple processes within the same integration service. And now we'll talk about the architecture of the integration service within a grid. So first of all, there is a very important term called load balancer. So the load balancer is a component of the Power Center integration service that whose job is to dispatch the Power Center integration service tasks. So all the tasks that you give to an IS, right? When you're running a workflow, inside that you give an email, you can have commands, you can have actual sessions which will run the mappings that you create. So all these tasks are dispatched to each of those Power Center integration service processes. Okay, and where to dispatch which job, the decision of it, the calculation of it is all done by this particular component, and this component is called load balancer. It matches the task requirements with the resource availability to kind of identify the best Power Center integration service process to run a task. So within an integration service running on a grid, there are multiple integration service processes, and when that integration service is given a task to run, it is the load balancer component which decides based on the resource availability on each of the nodes where the integration service is running, and the requirement of the task at hand, like where that task should be dispatched to. Okay, now I'll explain this more later, and when I run a particular session maybe this will get more clearer. But first of all, I should explain what do I mean by resources. So what do I mean when I say resources required by a task, and what do I mean when I say resources available on a node. So these are all the resources that are possible. Connection, any resource installed with Power Center, such as a plugin or a connection object. It could be relational, application, FTP. And so when you create a node, all connection resources are available by default, and you can disable, enable. And any session task that reads from or writes to a relational database requires one or more connection resources. And the workflow manager, actually the client tool, it assigns the connection resources to the session by default. The node name, a resource for the name of the node, and then operating system type. So it's a resource for the type of operating system on the node. So again, this is also a resource you can configure a particular session or task to require. Then there are lots of custom resources that the user can define. So there's example, a session task requires a custom resource if it accesses a custom transformation shared library, or if it requires a specific database client version. So suppose there is any specific library that you are using to perform a particular session in a mapping or something like that. There is a Java custom transformation, and you're using a particular Java API that you have available on only one of the nodes. So you can actually add that as a resource requirement to that session, and the load balancer component will take care that only the node which has that resource will be dispatched the task of that session. Okay, and files, there could be lots of files like source file, cache files, parameter files. Any of those files or directories or specific data which are available on a specific node, and you can add that as a resource, and load balancer will make sure that that task which requires that particular file is dispatched to a node which actually has access to that file or directory. Again, load balancer can have these settings for a domain, and you can determine how the load balancer dispatch tasks according to these two configurations. So first is the dispatch mode. The dispatch mode determines how the load balancer will kind of rank the tasks, okay, and how it will rank the nodes available, and then it will dispatch the tasks. So there are three modes for this dispatch mode. First is round robin, which uses node load metrics, or and it dispatches accordingly. So the round robin fashion is the first one. The second one is node load matrix, and the node load matrix will actually have two within it. I'll get to it. And then there's a second property for the load balancer configuration, which is the service level. So service levels establish dispatch priority among tasks that are waiting to be dispatched. You can create different service levels for a domain, and the workflow developer who is working with the workflows, right? From the workflow manager tool, he can assign a particular service level to a particular workflow. So the dispatch modes, there are three dispatch modes, as I said. The last two ones actually consider the load metrics, and the first one is round robin. So round robin is plain round robin fashion, which means it checks the maximum process threshold on each available node and excludes a node if dispatching a task causes the threshold to be exceeded. So of course you have a maximum process threshold for each of the machines, and for all the nodes which are capable of executing more tasks, the load balancer will keep them in a row and keep dispatching them tasks in round robin fashion. So like it will, if there are three nodes, node 1, node 2, node 3, the first task it will assign to node 1, the second to node 2, third to node 3, fourth again to node 1. And suppose after a few number of tasks, and uh, one of these nodes, say node 2, is having 10 processes running on it already, and we have an 11th task that is going to go to it, and the maximum process threshold is 10, then it will not assign it to node 2, it will assign it to node 3. And if node 3 is also already maxed out, it will assign it to node 1, and so on. The metric based, the load balancer evaluates nodes in a round robin fashion. It checks all resource provision threshold, not just the maximum process, and excludes a node if dispatching a task causes those thresholds to be exceeded, just like the max process threshold in round robin. And then the node balancer continues to evaluate nodes until it finds a node that can accept the task. So this mode kind of prevents overloading nodes when tasks have uneven computing requirements. So in round robin, we don't care about the requirements of the task. We just care that the number of the task on a particular node does not exceed the threshold. So it could be that due to round robin fashion, we assign, say, more heavier CPU intensive jobs to one node, and the other two nodes, while having the same number of tasks assigned to them, are actually not having that CPU intensive or memory intensive jobs, and that is why we are overutilizing one node or overloading one node. So metrics based helps with that. It prevents that overloading. But in metrics based, the first node that is able to accept the task is given the task. Now, third is adaptive. The load balancer ranks nodes according to the current CPU availability. It checks all resource provision thresholds and excludes a node if dispatching a task causes the threshold to be executed. Till this part, it is exactly like metrics based. This mode prevents overloading nodes and ensures the best performance on the grid that is not heavily loaded. So what this means is that we not only just check the tasks for the resource provision thresholds like metrics based, an additional step is then we rank them according to their capacity to perform that task, and we assign it to the best one, not just the first one that can perform the task, but the best one who has the maximum resource availability for performing that task. Now the service level. So as I said, the load balancer has two configurations. The first one was dispatch node, which had three dispatch modes: round robin, metrics based, and adaptive. And the second configuration for load balancer is service levels. Now the service levels establish priorities among the tasks that are waiting to be dispatched. When the load balancer has more tasks to dispatch than the power center integration service can run at the time, the load balancer places those tasks in the dispatch queue. So when I was explaining round robin, I was telling, right, that if the threshold exceeds for node 2, in the 11th task it will go to node 3. Now suppose node 3 is also having 10 tasks, it will then go back to node 1. And if node 1 also has 10 tasks, it cannot go anywhere. So it will put that task in a dispatch queue, and only when one of the nodes gets available or is freed up will this task come of the dispatch queue and is going to dispatch to whichever node is suited according to the dispatch mode. Now, when multiple tasks are waiting in this dispatch queue, the load balancer uses this second configuration, service levels, to determine the order in which to dispatch tasks from the queue. So it is to do with the priority of tasks in the dispatch queue. When multiple tasks are in dispatch queue, the load balancer dispatches tasks with service level high before tasks with service level low, because service level high has a higher dispatch priority. If a task with service level low waits in the dispatch queue for 2 hours, the load balancer changes its dispatch priority to the maximum priority so that the task does not remain in the dispatch queue indefinitely. So this is kind of preventing the starvation of a low service level task in the dispatch queue. Okay, so now for the architecture of the IaaS on a grid. So as I explained, there's an integration service which is running on a grid. Grid is an alias for multiple nodes, and for the integration service, there will be one integration service process running on each of those nodes. And these integration services processes will communicate with each other using a shared directory and using the master gateway node of the domain to figure out where the other processes are for that integration service. But even with all of this, for a service, we require someone to manage that multiple processes running on multiple machines. So that is where something called as a master integration service process comes up, and the concept of master and worker service process comes into the picture. So the master service process is a manager of the entire service, is chosen basically on a first come first serve basis. The process which comes up and registers with the master node of the domain first becomes the master IaaS process for that IaaS. So if that is not totally clear, what I mean is that when you enable the integration service, and just like I did, and there were two integration services processes that came up, one of them had to become the master. Now that choice is not done by any algorithm, it is simply whichever integration service process comes up first and registers itself with the master gateway node of the domain will become the master integration service process for that integration service. Now, how to figure out which one is the master integration service process? So we can actually do that. So here is our integration service that we just created. We can go to the nodes and the logs now. So in this log, we'll search for this term master. And there you see there is a log for the integration service which says that node OS node received a master election notification. Okay, so this message LN36919 says node name received a master election notification. In the IaaS service logs, you can look for this to figure out who is the master IaaS process, which node is the master integration service process. So the node that will be the for which this log will be the latest in the in IaaS service logs will be the current master service process. So it could be possible that if I go back here and say if I disable this particular process, the OS node process, and I say abort, now the process is stopping. Now this process will go down, and what we expect to happen is that the node 4 process, this last one, this becomes the master service process. So the way this works is that in a scenario where we actually stop the master service process, the gateway node tells the other processes in the grid on which the IaaS is running is that okay, the master has gone down, one of you guys become the master, and the first one to oblige becomes the master service process. In a scenario where the we don't shut down the master service process, it goes away for some reason, then the service manager or the node process tries to bring it up once again, and if it is not able to do that, then again it will go to the master gateway node and that guy will again ask all the other nodes and the integration service processes running on that node for this integration service to have one of them become the master process. Now, after becoming the master service process, the new master service process has the first duty of changing the configuration of the grid. So like before I stopped this, the configuration of this grid was probably that there are two nodes on the grid and there are two nodes in the integration service. Now after this particular change, this configuration needs to be changed and the process and the service needs to know that now there is only one node in the grid. So if we go to the logs for this integration service again, right, we should be able to, so if you see here, we should be able to see node 04 received a master election process which happened just now. Okay, and so 11.36919 became the master integration service process. And if you check the latest log, since nothing else has been running on there, you'll be able to see that the node OS node has been removed from the service. So it has changed the configuration of the integration service. The integration service, which was earlier having 3 nodes or 2 nodes with 2 processes, now it needs to change that configuration. So that is the job which the new master service process does. But that is not the only job actually. So as I explained, in case the master IS process goes down intentionally, if we shut it down, then immediately the master service manager will ask the other service processes to choose one of them to be master. And if it goes otherwise, the service manager will first try to bring up the IS process, which is the master once. And if it is not able to bring it up, then it will again ask the other processes to become master. Now, as I said, there are more than just one task for the master integration service process. It runs the workflow and workflow task, and it distributes the session, command, and predefined event wait task to itself and the other nodes. So a DTM process runs on each node where a session runs. If you run a session on a grid, a worker service process can run multiple DTM processes on different nodes to distribute session threads. So what this means is that the master service process is the guy who is responsible for running the workflows. Now workflows are a chain or sequence of tasks, right? So, but the workflow itself is kind of a logical entity. There's no process for a workflow, but it is something that needs to be evaluated and brought into the execution line to be executed. So logically a workflow is executed, but it is only within the integration service process, and in case of an IS on the grid, within the master integration service process, that this workflow gets executed. Within the workflow there are all these tasks like session task, command task, event wait, email, and all these tasks are dispatched by the load balancer component running within the master IS process to that one master IS process node and the other nodes, the worker process nodes as well. So like a DTM process, which is the executable process for a session task. So suppose you run a workflow, it has two session tasks, and we'll not talk about the case when the session itself is on a grid. We will only talk where workflow is on a grid. So it has session task 1 and session task 2. Now the workflow will logically be executed within the IS process, and each of the session 1 and session 2 will require a PM DTM process to be created, and the workflow can choose all the nodes within that IS process, within that integration service, right? So if the integration service is running on a grid and there are 3 nodes, it is the load balancer component running within the master integration service process which will choose where to dispatch the session 1 to and where to dispatch session 2 to, and wherever it dispatches a PM DTM process will come from the, it will be forked from the integration service process running on that particular node, and it will start executing the session. Now, the master service process receives requests, runs the workflow and workflow tasks, including the scheduler, and communicates with the worker service processes on the other nodes. Because it runs on the master service process node, the scheduler uses the date and time for the master service process node to start scheduled workflows. Again, if multiple nodes are having different time zone and timestamps, the scheduler, if you have scheduled a workflow, then the scheduler would be running on the master integration service process. So whichever node has the master integration service process, its timestamp and its time zone will be used to decide the schedule and when to particularly hit a scheduled workflow. And the master service process also runs the load balancer, as I said, which dispatches the task to the nodes in the grid. Again, it will dispatch to all the nodes in the grid, including the one on it which itself is running on. So if there are 3 nodes in the grid, say the node 1 has the master integration service process and 2 sessions come, the sessions could be dispatched to any of the 3 nodes, including node 1. And the worker service process running on other nodes act as load balancer agent. They have a component called LBA, and this load balancer agent is actually one of the load balancer agent running on the master integration process as well. Load balancer agent is something that responds to the request of load balancer. So load balancer, if the dispatch mode is say any of the node load metrics ones, it will ask the load balancer agent to give the information about the current load metric on your particular agent on your particular node, and each of those agents, including the one on the master integration service, will respond back to the load balancer, which again is running only on the master integration service process. And then those particular metrics will be calculated, and the load balancer will dispatch the task to a particular load balancer agent, and the load balancer agent on whichever integration service process it dispatches to will then run the task, be it a session, be it a command task, or whatever. Now, the worker service processes running on other nodes act as load balancer agent. The worker service process runs predefined event wait task within its process. It starts a process to run command task and a DTM process to run a session task. The master service process can also act as a worker service process. So the load balancer can distribute session, command, and predefined event wait tasks to the node that runs the master service process or to the other nodes. Just what I explained. So this is workflow on a grid architecture. So this particular workflow, suppose it was running on a grid which had 3 nodes, and it had say a command task, a predefined event wait task, 2 DTM tasks, okay, each with 1 session. So yeah, so 1 session will be executed as a DTM task. So what happens in this scenario, I'm just telling you what are the possibilities for a workflow on grid. The master service process starts the workflow and runs the workflow tasks other than the session, command, and predefined event wait task. Then the load balancer dispatches the session, command, and predefined event wait task to the other nodes. So as I said, the other task apart from these 3, session, command, and predefined event wait task, will be run on the master integration service process only. So if you have an email task, say, it will be run from the master integration service process only. So the load balancer will calculate the amounts. If according to the dispatch mode, it will prioritize them. If there are many processes on each of the nodes and the thresholds have been reached, it will put future task into the dispatch queue, and if there are multiple tasks in the dispatch queue, it will again prioritize according to the service level. All that we explained. Now in this scenario, the worker service process on node 2 starts a process to run a command task and starts the DTM to run a session task 1. And on node 3, again we have session tasks here, session task 2 and the predefined event wait task. Lastly, we have session on grid. So a session on grid is when the PowerSent integration service process runs the session on a grid. And so what I mean when I say a session can be a grid is that we can create partitions within the session and we can those could be horizontal or vertical, and each of those partitions could run on one of the nodes of the grid on which the integration service is configured on. So that load balancer can further disintegrate the session task itself into multiple tasks, and it can dispatch each one of them on one of the nodes. So in this scenario, the master IS process runs the workflow task. It also starts a temporary preparer DTM process, which becomes the master DTM process. The load balancer dispatches the command task and the session threads to nodes in the grid, and the worker service process runs the command task and starts the worker DTM process that runs the session threads. On node 3, the worker service process starts the worker DTM process that runs the session threads. So yeah, this is pretty confusing. Let me clarify this. So what happens is, let's forget about the command task and the other task for a bit. Let's suppose there is one session task that comes to the master IS process to be executed. That session itself is configured to run on a grid, which means that it has to be disintegrated further. That means there will be multiple processes on each of those nodes for that same session, multiple DTMs. Now those DTMs again would need to communicate with each other, share directories, and run in congruency and consistency so that the data can be properly manipulated and calculated upon. For that, we again need a manager, and that manager is something called as a master DTM process. So what happens is that the load balancer, it dispatches a master DTM process, which in its initial phase is called a preparer DTM process. So if you check the workflow logs, you will always see that for a session task, it will say that deploying the preparer DTM or deploying the preparer task. And once the prepared TTM has come up, only then later the session starts and the session executes. So that preparer DTM kind of prepares the mapping that it has to run, prepares the partitions that are supposed to come up, and informs the load balancer about what are all the tasks within that particular session that needs to be executed. And then the load balancer goes through its scenario of metrics or non-metrics or round robin fashion, and then it, for each of those particular partitions of that session, it will dispatch tasks to all the worker nodes, worker service processes of the integration service. So here the preparer DTM came up. It told load balancer there are these many session partitions that need to be executed, and then it kind of dispatched those to the other integration service process, the worker processes within this grid. Okay, and each of those worker DTM process that are forked by the worker integration service processes, or even the master integration service process can also have a worker DTM process, and then they all together perform the session task. So debugging an IS on grid. This is more of a discussing slide. So based on what you understood by the architecture, you can understand that master integration service process has a very important role. It is the connection point to all the other processes and tools to the IS. So if you're trying to start a workflow, that request goes directly to the master integration service process, and the load balancer then goes on and does its thing. So suppose the communication to the master service process is not able to happen. The process is up, but wherever you are trying to start the process from, suppose you are creating a start workflow command and you are firing it from a script, and that script is being run on a node A, and your master service process is node B, and this is when you say the start workflow command, it is supposed to contact node B and then find that service process and contact it and give it the particular workflow that you want to run. And if this communication is somehow not going well, and if you are able to afford in that scenario to have that node B bring down and make node A the master service process, or otherwise you can change your script to run from node B itself. That particular time from start workflow command running on node A then communicating to the master service process on node B can be reduced. So those kinds of things sometimes are helpful. Suppose a particular master service process is not able to communicate with a particular DTM. So a session started and it is running, and but it has to kind of relay back to the master service process that okay, this particular process completed with this particular values, and suppose in the link one of those values is required to decide which particular branch to take inside the workflow. There are multiple branches. If a value of an argument xyz is something, then execute this session, and if it is something else, then execute another session. So for those things, the DTM itself might need to communicate with the master service process, and in those scenarios, it is very important kind of to have the master service process be able to communicate with others. So in those things, you can kind of change the master service process. How you can do it is very easy. Just bring down all other service processes, and whichever one will be up will become the master service process, and then you can bring up the others as well, and they will just join the integration service, and the one that you kept up will remain the master. Restarting the IS or reassigning the grid is something that if you have changed the grid configurations on the domain level, if you have added a node to the grid, or if you have removed the node from the grid and somehow you don't see that reflected in the IS, it could be because the tables there have not been updated in the domain configuration or in the repository configuration. What you can do is you can reassign the grid to that particular IS. So in the admin console where we see the general properties, you can edit them, and then you can reselect a particular grid, and then you can set OK, and it will recycle the process and it will reassign those values. So if something on the database level has not been set, it will set it, and it will correctly show up the changes on the IS level as well, whatever changes you have made on the node level and the domain level. Lastly, we have these two traces, enable LB trace and LBA trace. These are logs for the load balancers, which are by default not on. In only in cases where we see issues with the load balancers, with the dispatching of tasks, if it is slow, or if it is not happening correctly, or if one node is getting more overloaded than the other, or the dispatch mode is not being correctly followed, we enable these traces, and these traces are created in the server bin. So what I'm going to do is I'm going to enable the LB trace, and then I'm going to execute a session, a workflow on a IS process that we just created, and I'm going to try to see the LB trace. So this is an integration service. It is running on a grid, and I'm going to say enable LB trace to yes for it. And now I'm going to execute a particular workflow on this, and then we're going to go and see what happens. So first, let me check who's the master service process. If you see in the process tab, these two processes are running, but let's see who's the latest master process. So node OS node is the master service process. Now I'm going to execute the workflow. Okay, so the workflow has just been executed, and I'm currently in this server directory in info home/server/bin. That's where I am for the node which is the current master. And if I do an lart here, um, yeah, so this is the same directory, and if you see there is an LB trace created here now. It's now at 125 and 126 now. And if we check this particular file, We'll see that node OS node has this resources and node 404 has these resources, and the load balancer has just started. So these entries are not very detailed because I don't have any resources configured on that particular node, but if it were, these would be logged here. So that was the enable LB trace, and similarly there is the property of enable LBA trace, which is the load balancer agent logs, and those are useful in scenarios where it's an issue with the load balancers. Okay, so that was it. The integration services when running on a grid. Thank you.